Hello, welcome to the video. The size of prehistoric animals is a topic a lot of people are interested in, and for good reason. While not everything was bigger in prehistory, a lot of wildlife was bigger in prehistoric times. While paleontology is mainly focused on prehistoric wildlife, paleontologists often look at living animals as a reference point for prehistoric animals. As an example, quite often we see lions, leopards, hyenas, and cheetahs interact with each other in Africa, in ways such as fighting over food. From this, we can assume that ancient ecosystems, such as the Kem Kem beds, would have featured similar interactions between Spinosaurus, Carcharodontosaurus, and Bahariasaurus. Quite often in living animals, individuals of a given species can differ in size, such as jaguars ranging from 36 to 158 kilograms. In this video, we'll be attempting to analyse the size variation and possible regional variance of Tyrannosaurus rex specimens. Here we'll be calculating the sizes of over 24 specimens of T-Rex to find an average size, talking about the limitations of the data, and going over several variables that affect this analysis. We'll also make comparisons to 3 other large theropod species and ask the question of how big could Tyrannosaurus have possibly gotten. The first part of this analysis was to gather the data required in the form of the sample size we would be using for this analysis and decide how we were to calculate the weights. The first part was easy to do. In 2022, Gregory S. Paul and colleagues published the now infamous study that tried to split Tyrannosaurus rex into Tyrannosaurus rex, Regina, and Imperator. This focus of the paper did not end up being as well received as Paul probably wanted it to be. However, one part that slipped under the radar was that a table was included that had measurements for the femurs of more than 24 Tyrannosaurus specimens. Alongside that, the 2008 book Tyrannosaurus rex, the Tyrant King included a similar table. 2019's paper describing the specimen nicknamed Scotty also lists several specimens. The final source used was a post from Instagram about the most recent giant Tyrannosaurus specimen, nicknamed Goliath. After having gathered the data, each specimen's mass was calculated using an allometry calculator, which uses a formula first published in a 2014 study. This calculator will be linked below in the description. Given the paper describing Scotty had him as being estimated at 8,870 kilograms, plus or minus 25%, 2 further values were calculated for each specimen, one being the original value minus 25%, and the other was the original value plus 25%. All values were used to estimate the average size for Tyrannosaurus rex based on this sample size. Also listed off for each Tyrannosaurus specimen was the formation they were from, so we can see if there is a regional variation in the size of Tyrannosaurus. One question brought up was of specimen age. Only 5 Tyrannosaurus rex specimens are confirmed adults, with the maturity being seen as around 22 to 23 years for the species. The specimen MOR 555 was reportedly only 18 at the age of death and still might have had room to grow, and so could a lot of other specimens in this sample size. This means that a sample size of fully grown Tyrannosaurus specimens would likely result in a higher average, but for now this sample size is what we must work with and what we'll be using until further age testing of these specimens is conducted. 2 specimens were removed from this sample for being too small, however, given a circumference of only 305mm for one of them, and the other only had a circumference of 430mm. Anything above that number, however, was kept in, and for those wanting to know those specimen sizes, they will be shown on screen. The middle value estimates came in at an average of 6.7 metric tons, while the lower value resulted in 5 metric tons, and the higher value was 8.4. The overall range in size was 3.4 to 14.3 metric tons, making for a size variance greater than 415% between the smallest and largest estimates. The lower end's range was 3.4 to 8.6, the middle value was 4.6 to 11.5, and the higher end is 5.8 to 14.3 metric tons. Femur circumference varied from 465 to 647.7mm, or a variance greater than 139%. The largest specimens were Goliath at 11.5, ED Cope at 10.7, Scotty at 8.9, MOR 1128, RMDRC 2002.mi-001, and Sue tied at 8.5, followed by Sampson at 7.7 metric tons. All specimens have a standard deviation of 25%. 22 specimens, or about 81%, came from the Hell Creek Formation, while the other 19% was made up of 2 specimens from the Lance Formation, and 1 each for the Scholard, Willow Creek, and Frenchman formations. This meant for regional variation of the specimens, nothing could really be done. For those wanting to know anyway, the average for Hell Creek was 6,778 kilograms compared to 6,700 kilograms across all specimens. At that size, this is a negligible difference. The main variable that a lot of people watching this video will bring up is the sample size. While most other large theropod dinosaurs, such as Giganotosaurus, Tyrannotitan, and Mapusaurus are comparable to some Tyrannosaurus specimens, they have nowhere near as many specimens as Tyrannosaurus rex. Giganotosaurus has been known for 30 years, with only one specimen being of decent completeness, that being the holotype specimen. Some minor referred material exists, but doesn't really add much to our knowledge on Giganotosaurus. Tyrannotitan is known from only 2 decent specimens and some minor referred material. Mapusaurus was found in a bone bed shortly after Giganotosaurus was described, with the bone bed consisting of what Correa and Curry, 2006, said was a minimum of 7 to 9 individuals, ranging from 5 to 11 meters in length. In sheer volume, Mapusaurus is the best out of these 3 Carcharodontosaurids, but it is still not as good as Tyrannosaurus rex in terms of both total number and completeness of each given individual. However, it has been estimated that throughout the roughly 2 million years T-Rex existed, that there was potentially 2.5 billion T-Rex individuals, with there being 20,000 at any given time. While significant, it is worth keeping in mind that for living animals, similar and even smaller sample sizes have been used than this dataset. As an example, Sundquist and Sundquist 2002 listed tables of weights and lengths on wildcat species from different sources. Look at what is shown for the leopard, lion, tiger, jaguar, and snow leopard sections. The largest sample size of those species was of 36 male jaguars from the Pantanal in southern Brazil, averaging 96 kilos, ranging from 71 to 119 kilograms. All the sample sizes in the snow leopard table are also in the single digits. While some of you watching might not find this to be the best comparison, it's worth noting that the cat family has also existed for millions of years. So this is when you are asked, how many jaguars do you think existed, and how good do you think a sample size of 36 are at representing that? And before someone says it, yes, Sundquist and Sundquist 2002 does list off multiple sources for most cat species in the book regarding their weight, and you can just add those all up to get a larger sample size. But even then, a sample size of 200 still isn't much better, given, as asked several seconds ago, how many jaguars do you think have existed throughout natural history? Zoologists, like paleontologists, are limited by published scientific data and research on a given subject, meaning experts in both fields need to work with what they have. So you might think we'd have better data for living animals, and you'd be correct, but it's not leagues and bounds closer to 100% certainty than the sample sizes. Another variable worth talking about is that the main focus of this analysis, geographical size variation, isn't really worth considering, given the majority of T-Rex specimens are from the Hell Creek Formation. The largest specimen in this dataset, Goliath, has currently not had its formation of origin confirmed, but according to conversations with the Vividen, ChatGPT, and further research to back up both sources, the most likely formation is Hell Creek. Hence why in the spreadsheet, Goliath's fossil formation is listed as Hell Creek. Most notable specimens in this spreadsheet, Goliath, E.D. Cope, and CM9380, among others, are all of Hell Creek origin. Probably the most notable of all non-Hell Creek specimens is Scotty, who is third largest in this dataset and originates from the Frenchman Formation in Canada. Out of the 6 specimens that potentially surpass 10 metric tons when alive, Scotty is the only specimen confirmed to not be from Hell Creek. And overall, only 5 specimens are not from Hell Creek. 2 are from the Lance Formation, 1 from Scollard Formation, 1 from Willow Creek Formation, and then, as mentioned, Scotty from the Frenchman Formation. This can most likely be attributed to Hell Creek being one of the most famous fossil formations in the world. In North America, the 2 main fossil formations people would be familiar with are the Hell Creek and Morrison formations. Several famous species are known from the Hell Creek Formation, such as Triceratops and Ankylosaurus, and it's the place the Tyrannosaurus holotype was found in. This would lead to a bias in favour of searching for Hell Creek dinosaurs, and as a result, a lot of Tyrannosaurus specimens originating from Hell Creek, or in the case of Goliath, most likely being from Hell Creek. Another variable to consider is measuring standards. The Vividen has mentioned in some videos that updates have been made and found that Scotty is not actually larger than Sue, and that Sue might be slightly larger. In a recent video he did on E.D. Cope, he placed both Sue and Scotty at a femur circumference of 580mm. Out of all the Tyrannosaurus specimens that are possibly over 10 metric tons in weight, this makes 580mm the most common circumference. Some of you might have also noticed contradictory numbers in the spreadsheet and its sources. To clarify, whenever contradictory measurements were found, an average was taken and that was used for the calculations instead, since it's not always clear where scientists are measuring from. Another variable to consider is age. We are not sure about the age of all specimens in this data sample, and as mentioned earlier, only a small number of these specimens have been scientifically tested to identify their age. If all these specimens were grown up, the average would most likely be higher, but for now this is what we must work with. The final variable to consider is the reliability of the calculations. The Vividen has mentioned in videos he has done on the specimen E.D. Cope that allometric scaling from femur circumference tends to underestimate the size of bipeds. The preferable method would be volumetric models for all 27 specimens in this data sample, given it tends to be more reliable. However, given that some of these specimens are known solely from femurs with maybe some other scant material, allometry is the preferred route over volumetric in this context. A 3D model could be made of all these specimens by extrapolating sizes based on other more complete specimens, but these models rely on the extrapolations being true to the actual animal. With this considered, this makes femur circumference the preferred method, given it can be more widely applied to all specimens than 3D modelling. Given we have a specimen in the sample with a femur circumference of 647.7mm, and due to statistics, Goliath is probably not the largest Tyrannosaurus to ever live, how big would the biggest T-Rex be? Well, in 2024, a study was published that used alligators as a basis to estimate that and arrived at 15 metric tons, which would require a femur circumference of around 714mm. Goliath is estimated in this spreadsheet to be anywhere from 8.6 to 14.3 metric tons, averaging out to 11.5. This means that Goliath, at the higher end, is close to that hypothetical 15 metric ton Tyrannosaurus, although it is doubtful Goliath was ever that big. Perhaps if he fattened up a little and had a full stomach, then maybe he would have been that big. With that in mind, for fun, let's say that perhaps there was some individuals running around with a femur of up around 7 or 750mm in circumference. These numbers would yield Tyrannosaurus specimens at 14.2 and 17.2 metric tons respectively. With the standard deviation of 25% in mind, that would place this 750mm circumference pulled out of thin air for fun at 30 kilograms shy of 21.5 metric tons. This obviously brings the biomechanics of such creature into speculation, given everything has a limit, and this is probably starting to reach the limit of Tyrannosaurus, if it hasn't already. But overall, we'll most likely never know the max size of Tyrannosaurus, but we can say that the largest specimens we do have are in fact large animals, even by Tyrannosaurus standards. It is best to focus on the real rather than the fanciful. As for comparisons with other theropod dinosaurs, while we do have femoral measurements for other theropod species, to which another table is made for that, we will only be focusing on the previously three mentioned theropods. Those are Maposaurus rosier, Tyrannotitan tubulensis, and Giganotosaurus carolinii. These three are all large Carcharodontosaurus species that come from South America, although they didn't coexist with each other. Giganotosaurus was described in 1995 and, as mentioned, has only one known specimen of decent material. Said material consists of a reasonably complete skeleton that includes both femora. The holotype has a femur of 520mm in circumference and was calculated to weigh 6.26 metric tons, making Giganotosaurus roughly 436 kilograms lighter than the average Tyrannosaurus specimen. Tyrannotitan was described in 2005 and has two specimens that both, luckily, have measurements for their femur circumference, one being 505mm and the other 520mm. The largest of these two specimens is equal in weight to Giganotosaurus, so as you may have guessed, it's smaller than the average Tyrannosaurus specimen. Maposaurus was originally considered to be Giganotosaurus material, but in 2006 it was placed in its own genus. Sadly for Maposaurus, it is the smallest of these three, with the femur of the largest Maposaurus specimen being only 435mm in circumference. Based on femur circumference, the largest specimen would have only weighed 3.8 metric tons, making it comparable to the smallest Tyrannosaurus specimens in this dataset. Tyrannosaurus, at the current moment, keeps itself on top as the largest species based on known specimens. It is worth noting, however, that if any of these three Carcharodontosaurids had comparable numbers of fossil specimens with well-preserved femurs, we would most likely find specimens that would rival the largest known Tyrannosaurus specimens. These theropods come from countries not as well developed as the United States and Canada, both in terms of paleontological progress and economical progress, leading to a lack of discoveries of large theropod specimens from said countries. We know they can produce such theropod discoveries, as is evident from Zoochang tyrannus and Tyrannosaurus in Asia, Mosasaurus, Tyrannotitan and Giganosaurus in South America, and Carcharodontosaurus and Spinosaurus in North America. Research needs to be more focused on these other theropods rather than Tyrannosaurus if we want to see the variability of these other theropods and just how big they could truly get. The primary goal of this analysis was to look at Tyrannosaurus geographical size variability, but given most of the specimens in this sample are from Hell Creek, that is not possible to answer currently. The main goal was to see which fossil formation has the largest specimens on average, but that is not determinable as of November 2025, the month this script is being written. Perhaps by 2050 we'll have enough to revise this dataset, but for now we can only dream. However, we did see that size variation within this species is quite great, with a lot of specimens being over 10 metric tons in mass on the higher end, but there is still a lot that are smaller and more comparable in weight to specimens of other known large theropod species. Thanks to the YouTube channel The Vivid and Palaeontology Evolved for looking over this video analysis script, helping in answering some questions and with finding research material. That is all for this video, so hopefully you liked, shared and subscribed, and I'll see you next time I upload.